A thermobaric weapon, which includes the type known as a fuel-air bomb, is an explosive weapon that produces a blast wave of a significantly longer duration than those produced by condensed explosives. This is useful in military applications where its longer duration increases the numbers of casualties and causes more damage to structures. There are many different variants of thermobaric weapons rounds that can be fitted to handheld launchers such as rocket-propelled grenades and anti-tank weapons. Thermobaric explosives rely on oxygen from the surrounding air, whereas most conventional explosives consist of a fuel oxidizer premix. For instance, gunpowder contains 25% fuel and 75% oxidizer. Thus, on a weight-for-weight basis, they are significantly more energetic than normal condensed explosives. Their reliance on atmospheric oxygen makes them unsuitable for use underwater, at high altitude or in adverse weather. However, they have significant advantages when deployed inside confined environments such as tunnels, caves, and bunkers. Terminology. The term thermobaric is derived from the Greek words for heat and pressure, thermobariko. Other terms used for this family of weapons are high-impulse thermobaric weapons, heat and pressure weapons, vacuum bombs, or fuel-air explosives. Mechanism. In contrast to condensed explosive where oxidation in a confined region produces a blast front from essentially a point source, here a flame front accelerates to a large volume producing pressure fronts both within the mixture of fuel and oxidant and in the surrounding air. Thermobaric explosives apply the principles underlying accidental unconfined vapor cloud explosions, UVCE, which include those from dispersions of flammable dusts and droplets. In previous times they were most often encountered in flour mills and their storage containers, and later in coal mines, but now most commonly in discharged oil tankers and refineries. The most recent being at Buncefield in the UK, where the blast wave woke people 150 kilometers, 93 miles from its center. A typical weapon consists of a container packed with a fuel substance, in the center of which is a small conventional explosive, scatter charge. Fuels are chosen on the basis of the exothermicity of their oxidation, ranging from powdered metal such as aluminium or magnesium, or organic materials, possibly with a self-contained partial oxidant. The most recent development involves the use of nanofuels. A thermobaric bomb's effective yield requires the most appropriate combination of a number of factors. Among these are how well the fuel is dispersed, how rapidly it mixes with the surrounding atmosphere, and the initiation of the igniter and its position relative to the container of fuel. In some cases separate charges are used to disperse and ignite the fuel. In other designs stronger cases allow the fuel to be contained long enough for the fuel to heat to well above its auto-ignition temperature, so that, even its cooling during expansion from the container, results in rapid ignition once the mixture is within conventional flammability limits. It is important to note that conventional upper and lower limits of flammability apply to such weapons. Close-in, blast from the dispersal charge, compressing and heating the surrounding atmosphere, will have some influence on the lower limit. The upper limit has been demonstrated strongly to influence the ignition of fogs above pools of oil. This weakness may be eliminated by designs where the fuel is preheated well above its ignition temperature, so that its cooling during its dispersion still results in a minimal ignition delay on mixing. The continual combustion of the outer layer of fuel molecules as they come into contact with the air generates additional heat which maintains the temperature of the interior of the fireball, and thus sustains the detonation. In confinement, a series of reflective shock waves are generated, which maintain the fireball and can extend its duration to between 10 and 50 milliseconds as exothermic recombination reactions occur. Further damage can result as the gases cool and pressure drops sharply, leading to a partial vacuum. powerful enough to cause physical damage to people and structures. This effect has given rise to the misnomer, vacuum bomb. Piston type after burning is also believed to occur in such structures, as flame fronts accelerate through it. The overpressure within the detonation can reach 430 pounds per square inch, 3 megapascals, and the temperature can be 4,500 to 5,400 degrees Fahrenheit, 2,500 to 3,000 degrees Celsius. Outside the cloud, a blast wave travels at over 2 miles per second, 3.2 kilometers per second, 7,200 mph. Fuel-air explosive. A fuel-air explosive (FAE) device consists of a container of fuel and two separate explosive charges. After the munition is dropped or fired, the first explosive charge bursts open the container at a predetermined height and disperses the fuel in a cloud that mixes with atmospheric oxygen. The size of the cloud varies with the size of the munition. The cloud of fuel flows around objects and into structures. The second charge then detonates the cloud, creating a massive blast wave. The blast wave destroys unreinforced buildings and equipment and kills and injures people. The anti-personnel effect of the blast wave is more severe in foxholes, on people with body armor, and in enclosed spaces such as caves, buildings, and bunkers. Fuel-air explosives were first developed and used in Vietnam by the United States. Soviet scientists, however, quickly developed their own FAE weapons, which were reportedly used against China in the Sino-Soviet border conflict and in Afghanistan. Since then, research and development has continued, and currently Russian forces field a wide array of third-generation FAE warheads. Effect. A Human Rights Watch report of the 1st of February 2000 quotes a study made by the U.S. Defense Intelligence Agency. The blast-kill mechanism against living targets is unique and unpleasant. What kills is the pressure wave, and more importantly, the subsequent rarefaction vacuum, which ruptures the lungs. If the fuel deflagrates but does not detonate, victims will be severely burned and will probably also inhale the burning fuel. Since the most common FAE fuels, ethylene oxide and propylene oxide, are highly toxic, undetonated FAE should prove as lethal to personnel caught within the cloud as most chemical agents. According to a separate U.S. Central Intelligence Agency study, the effect of an FAE explosion within confined spaces is immense. Those near the ignition point are obliterated. Those at the fringe are likely to suffer many internal, and thus invisible injuries, including burst eardrums and crushed inner ear organs, severe concussions, ruptured lungs and internal organs, and possibly blindness. Another Defense Intelligence Agency document speculates that because the shock and pressure waves cause minimal damage to brain tissue, it is possible that victims of FAEs are not rendered unconscious by the blast, but instead suffer for several seconds or minutes while they suffocate. Development history: Soviet and Russian developments. A RPOA rocket and launcher. The Soviet armed forces extensively developed FAE weapons, such as the RPOA, and are known to have used them in Chechnya. The Russian armed forces have developed thermobaric ammunition variants for several of their weapons, such as the TGB-7V thermobaric grenade with a lethality radius of 10 meters, 33 feet, which can be launched from a RPG-7. The GM-94 is a 43mm pump-action grenade launcher which is designed mainly to fire thermobaric grenades for close-quarters combat. With the grenade weighing 250 grams, 8.8 ounces, and holding the 160 grams, 5.6 ounces explosive mixture, its lethality radius is 3 meters, 9.8 feet. The RPOA and upgraded RPOM are infantry portable RPGs designed to fire thermobaric rockets. The RPOM, for instance, has a thermobaric warhead with a TNT equivalence of 5.5 kilograms, 12 pounds of TNT and similar destructive capabilities as a 152 mm high explosive fragmentation artillery shell. The RSGH-1 and the RSGH-2 are thermobaric variants of the RPG-27 and RPG-26 respectively. Of the two, the RSGH-1 is the more powerful variant, with its warhead having a 10 meters, 33 feet lethality radius and producing the same effects of about 6 kilograms, 13 pounds of TNT. The RMG is a further derivative of the RPG-26 that uses a tandem charge warhead, whereby the precursor heat warhead blasts an opening for the main thermobaric charge to enter and detonate inside. The RMG's precursor heat warhead can penetrate 300 mm of reinforced concrete or over 100 mm of RHA, thus allowing the 105 mm, 4.1 in diameter thermobaric warhead to detonate inside. The other examples include the SACLOS or millimeter wave radar guided thermobaric variants of the 9M123 Karazandma, the 9M133F-1 thermobaric warhead variant of the 9M133 Hornet and the 9M131F thermobaric warhead variant of the 9K115-2 Metis-M, all of which are anti-tank missiles. The Hornet has since been upgraded to the Hornetium, and its thermobaric variant has a maximum range of 10 kilometers, 6.2 miles, and has the TNT equivalent of 7 kilograms, 15 pounds of TNT. The 300 mm 9N174 thermobaric cluster warhead rocket was built to be fired from the BM-30 Smerch MLRS. A dedicated carrier of thermobaric weapons is the purpose-built TOS-1, a 24-tube MLRS designed to fire 220 mm caliber thermobaric rockets. A full salvo from the TOS-1 will cover a rectangle 200 by 400 meters, for a total area of 80,000 square meters, 0.031 square mi. The Iskander-M theater ballistic missile can also carry a 700 kilograms, 1,500 pounds thermobaric warhead. Many Russian Air Force munitions also have thermobaric variants. The 80 mm S-8 rocket has the S-8DM and S-8DF thermobaric variants. The S-8's larger 122 mm brother, the S-13 rocket, has the S-13D and S-13DF thermobaric variants. The S-13DF'-S warhead weighs only 32 kilograms, 71 pounds, but its power is equivalent to 40 kilograms, 88 pounds of TNT. The KAB-500-OD variant of the KAB-500KR has a 250 kilograms, 550 pounds thermobaric warhead. The ODAB-500PM and ODAB-500PMV unguided bombs carry a 190 kilograms, 420 pounds fuel-air explosive each. The KAB-1500S GLENDAS GPS-guided 1,500 kilograms, 3,300 pounds bomb also has a thermobaric variant. Accordingly, its fireball will cover over a 150-meter, 490 feet radius and its lethality zone is a 500-meter, 1,600 feet radius. The 9M120 Atakovi and the 9K114 Sherm ATGMs both have thermobaric variants. In September 2007, Russia successfully exploded the largest thermobaric weapon ever made. The weapon's yield was reportedly greater than that of the smallest dial-yield nuclear weapons at their lowest settings. Russia named this particular ordnance the "father of all bombs" in response to the United States-developed Massive Ordnance Air Blast (MOAB) bomb, whose backronym is the "mother of all bombs," and which previously held the accolade of the most powerful non-nuclear weapon in history. The bomb contains a 14,000-pound, 6,400 kilograms charge of a liquid fuel such as ethylene oxide, mixed with an energetic nanoparticle such as aluminium, surrounding the high explosive burster that when detonated, created an explosion equivalent to 88,000 pounds, 40,000 kilograms of TNT, though this is disputed. U.S. developments. A. BLU-72/B bomb on USAF A-1E taken off from Nakhanfanam in September 1968. The XM-1060 40mm grenade is a small arms thermobaric device, which was delivered to U.S. forces in April 2003. Since the 2003 invasion of Iraq, the U.S. Marine Corps has introduced a thermobaric, novel explosive, SMAWME round for the Mk-153 SMAW rocket launcher. One team of Marines reported that they had destroyed a large one-story masonry-type building with one round from 100 yards, 91 meters. The 106-pound, 48 kilograms, AGM-114N Hellfire metal augmented charge introduced in 2003 in Iraq contains a thermobaric explosive fill, using fluoridated aluminium layered between the charge casing and a PBXN-112 explosive mixture. When the PBXN-112 detonates, the aluminium mixture is dispersed and rapidly burns. The resultant sustained high pressure is extremely effective against people and structures. History: military use. U.S. Navy, BLU-118B being prepared for shipping for use in Afghanistan, the 5th of March 2002. First experiments were conducted in Germany during World War II, led by Mario Zippermayer. The German bombs used coal dust as fuel and were extensively tested in 1943 and 1944, but did not reach mass production before the war ended. The TOS-1 system was test-fired in Panjshir Valley during Soviet war in Afghanistan in the early 1980s. Unconfirmed reports suggest Russian military forces used ground-delivered thermobaric weapons in the battle for Grozny, First and Second Chechen Wars, to attack Dugan Chechen fighters. The use of both TOS-1 heavy MLRS and RPOA small shoulder-fired rocket system in the Chechen Wars is reported to have occurred. During the 2004 Beslan school hostage crisis, it is theorized that a multitude of handheld thermobaric weapons were used by the Russian armed forces in their efforts to retake the school. The RPOA and either the TGB-7V thermobaric rocket from the RPG-7 or rockets from either the RSHG-1 or the RSHG-2 is claimed to have been used by the Spetsnaz during the initial storming of the school. At least 3 and as many as 9 RPOA casings were later found at the positions of the Spetsnaz. 56. The Russian government later admitted to the use of the RPOA during the crisis. According to UK Ministry of Defence, British military forces have also used thermobaric weapons in their AGM-114N Hellfire missiles, carried by Apache helicopters and UAVs against the Taliban in the war in Afghanistan. The US military also used thermobaric weapons in Afghanistan. On the 3rd of March 2002, a single 2,000 pounds, 910 kilograms laser-guided thermobaric bomb was used by the U.S. Army against cave complexes in which Al-Qaeda and Taliban fighters had taken refuge in the Gardez region of Afghanistan. The SMAW-1E was used by the U.S. Marines during the First Battle of Fallujah and Second Battle of Fallujah. Non-military use thermobaric and fuel-air explosives have been used in guerrilla warfare since the 1983 Beirut barracks bombing in Lebanon, which used a gas-enhanced explosive mechanism, probably propane, butane or acetylene. The explosive used by the bombers in the 1993 World Trade Center bombing incorporated the FAE principle, using 3 tanks of bottled hydrogen gas to enhance the blast. Gemma Islamiyah bombers used a shock-dispersed solid fuel charge, based on the thermobaric principle, to attack the Sari nightclub in the 2002 Bali bombings. Fiction. The idea of an HIT explosion was used to describe the destruction of the Centers for Disease Control and Prevention in the Season 1 finale of The Walking Dead. A fuel air bomb was going to be used to destroy a virus-infected area in the movie Outbreak. Use and results of a thermobaric weapon at the Battle of Yonkers are described in Max Brooks' World War Z. A fuel air bomb is dropped in the center of a city near the end of the space opera Judas Unchained in an attempt to eliminate the main antagonist, an alien with mind control capabilities. The blast from the bomb is focused by dropping it into a walled plaza, rather than allowing it to spread in all directions. However, damage and injuries still occurred outside this area due to the power of the weapon, causing the use of a second bomb to be called off for fear of further collateral damage. A tank, known as the Thermobaric tank, codenamed Hammer, is used in the video game prototype. The Fighter A-10, piloted by Glenda, have 2 fuel air bombs in its supply, in the video game Aerofighter's Assault. One of the higher-tiered, and thus unlocked either late in the game or through a cheat, airstrikes in Mercenaries. Playground of Destruction is the fuel air bomb. It costs $52,000 from the Merchant of Menace and is delivered by the Chinese Sukhoi Su-25. Although the Bunker Buster and cruise missile are more powerful, the fuel air bomb has a wider blast radius.